So in this video, we're going to talk about a lot more vocabulary words. We're going to be talking about sampling errors and bias and just different measures and other variables that are going to pop up. I got my pen working so I can write on the screen today. So I'm excited about that. And on a personal note, I'm doing this like blindfold TikTok challenge tomorrow where this gal is going to just like change my hairstyle. So this is the last time it's going to look like this. I don't know what it's going to look like in the next video, but I will share when I find out. Okay, so here is my screen here. So 1.2, sampling errors and bias. Bunch of vocabulary words, but I just want to go through, oops, why is my mouse? Oh, there we go. Just want to go through some of the basics. A sampling error is a really big one. It's the error caused by the actual process of sampling that varies from sample to sample because, and this is the big part here, because the sample is not the whole population. That's going to be a big error. So when we see that happening, automatic sampling error. There's non-sampling errors where it's something like human error, something that's not related to the sample process. And then there's bias where people's individual opinions, you probably heard of the word bias before, where their individual opinions influence the results. And then there's sampling bias, where they just are not properly selecting participants, or some members are not as likely to be chosen as others. That would be the sampling bias. So that just has to do with how the sample is chosen, where it's not an error because they just kind of made a sample. Technically, it's the population, but some people aren't necessarily going to be like, what's a good example? Say we do a survey of people in Merced County, and the whole survey, we email a bunch of people in Merced County and say, click this link and go ahead and fill out the survey. Well, there could be huge chunks of people we miss, like people that don't have internet or email, or maybe they have it, but they're just an older generation and they don't quite get it, or they don't want to figure it out. So there's just chunks of people that would be missed, even though we're surveying people in Merced about Merced. It's not necessarily getting all the different types of people. Okay. Anyways, moving on, we have 4 scenarios here, and we want to say which one contains a sampling error. So sampling error is the big one. So when I highlighted, it says the sample is not the whole population. It does not represent the whole population. Okay, that's worded a little weird. I don't mean the sample has to equal the population. I mean the sample has to represent the population. If I was to survey people in the United States, I do not want to interview every single person in the United States. I would want a small sample, but it needs to represent the whole population. Okay, that's the key. So number 1, sampling error. Let's look at the 4 different studies. So the first one, a study is conducted to determine the favorite subject of all students in your high school. So students in your homeroom class were used as an example. So sampling error, we're saying, is our sample representative of the population? So right off the bat, there could be more than one answer, but right off the bat, we know this has a sampling error because the homeroom class was the sample, but the population was all the students. Oh, just discovered a new button on my pen that erases instead of writes. Okay, so this right here is the population. Oh, I'm going to click that a lot. That's in a weird space. And this right here, you can see is the sample. Okay, so that's definitely a sampling error because the sample does not represent the population. Just to be clear as to why that is, people in your homeroom class, we're just going to be very generic. Let's just say it's everyone. We don't know how they were chosen. So typically homeroom, like first period, that's going to be like your math class, which is typically people in your grade, which is going to be people that all have that math class in common. That doesn't represent every single grade at the whole school, every single academic ability at the whole school. Like there's a lot of pieces missing. We just take the homeroom class. So we would want the sample to represent the population. All right, the second one, a study is conducted about where the best travel destinations are, Europe or Asia. People who live in big cities throughout Europe were used as a sample. Okay, Well, sampling error has to do with sample representing population. And here it doesn't say who the population is. So maybe they want to know a study about Europeans, what the Europeans think about best travel destinations. Is it Europe or Asia? So they ask people in Europe. Okay, I don't know. I just made that up. What if they want to know what Americans think and they ask people in Europe? Like, so it could be representative, it could not. We don't have enough information. They're trying to trick you by using Europe and Asia, that phrase in the question, but then they're asking about Europe. It's just a study asking where's the best place to travel. It doesn't say who they're targeting. So we don't know. There's not enough information. I would say this is probably a dumb study, but it's not a sampling error. Okay, next up, a hospital. Well, I put a question mark. I don't mean there's not, what I mean by that is not enough info to determine. That's what is a better answer. Not enough info. Because the question mark means we don't know what the population is. Okay. Third one, a hospital conducts a study about a new heart monitoring software. All patients, so there's your population, all patients who use the software are used in the sample. Okay, sounds tedious, but it represents it. Everyone in the population is everyone in the sample. Sample definitely represents the population. So that is good. That is not our answer. So these two are not our answer. The first one is definitely an error. Let's look at the last one. A study is conducted by a cereal manufacturer about 2 brands of cereal. And a question on the survey says, do you prefer the delicious taste of brand X or the taste of brand Y? Okay, so that is going to be bias. See here it says when an individual's opinion or preference influences the result, the delicious taste of brand X, you are influencing their opinion. That's bias. These other ones that we cross off, they're bad, but they're just not bad in the way we're looking for. We're looking for specifically sampling error. That's not sampling error. So the first one is, and the first one's the only one because the population and the sample don't match. Okay, more words. Okay, so we have this is more just words. There's not really any examples to write down, just to talk about some words that lead to misleading statistics. So the data can be misleading when the sample is biased. So like when the data collected from the sample is not representative of the entire population. If the sample is too small, now we're just going to pause on that real quick. Too small for you and too small for me don't necessarily mean the same thing. So don't put a number on that. Right now, we're just kind of feel our way around. We will give it a specific number of what too small is in the future. And it's probably a lot smaller than you think it is. But, you know, if we want to know what everyone in America thinks, so we ask our next door neighbor. We just asked that one guy. Okay, that's probably too small. That one guy doesn't represent all of America, you know, but we don't need to ask a whole bunch of people. We just need to have a really good sample. Okay, so self-selected samples can be biased. They're unreliable. And what I mean by self-selected is I give you a survey in the mail, and whoever responds to that is who's in my sample. Well, you have to go get your mail. For me, I have to like drive 10 minutes to the post office to get my mail. Then you have to fill out the mail, and then you have to return the mail. Like there's a lot of ways that people are just going to end up throwing this in the trash. So that's not really great. Self-selected samples are not great. They're voluntary. You choose to participate. And so we don't know anything about your background. We don't know if it's a good sample. Self-funded or self-interest studies are also biased. Well, yeah, if big tobacco is going to pay for a study and they're going to pay a lot of money, the study's probably going to say that tobacco is not that bad. So we don't want surveys to be self-funded. And then also the phrasing of the question, like we talked about over here with the delicious taste of brand X. Okay, so one type of misleading data is when the sample is biased. Another type is an outlier. So an outlier, we have the definition up here. It says a data point that is distant from all the other data points. So look at this store right here, or restaurant. The restaurant says the average price of one of their meals is $7 on average. but the prices, the actual meals are $1, $9, $8.50, or $10, right? Like they have a dollar menu, they're counting that as a meal. So of the 4 items, 3 of them are more than $7. They're more than $8. But because we have this little $1 menu item right here, we're able to bring the average down. The average is actually 7. We'll calculate average in chapter 2. So that 7 is not really representative because you're going to go in there and think, okay, average is 7. So I might pay $5. I might pay $7. Well, you can't pay either of those prices unless you're ordering things only off the dollar menu. So that is another reason data could be misleading, is with an outlier. Third way it's misleading is they're displayed incorrectly. So these bar graphs are both showing the same thing. A is at 120 and B is at 150 on both of them. But on this first one, you know, if it goes, we don't really know where 0 is. We don't really know any of these other numbers besides 120 and 150. So if you wanted to say that 2 things were kind of close together, you would show this picture. And if you wanted to say things are far apart, you would show this second picture. But really, they both have the same numbers of 120 and 150. One's just zoomed in more or starting at a different number. Like this one probably starts at 0, whereas this one, I don't know, can you see my mouse? Okay, let me just write, I forgot about that. Okay, this one probably starts at 0, whereas this one might start at like 100, right? And then that 100 is closer to 120. So same info, different pictures, gives you different opinions. Okay, last one. There's not even any examples here. I kind of just wrote out the examples already. 2 bar graphs. Yeah, misleading. Or did I? Yeah, they're kind of like the same idea. The bar graphs. It's misleading because the data is inaccurate or incomplete. Okay, so going on to variables and measure of data, we talked about observational versus experiment in the last video. If it's an experiment, we talked about something that was being controlled. What's being controlled is the explanatory variable. So this is what is controlled. This is weird because my screen is like up. I have a laptop like this and I'm writing like this. Weird. Okay, what is controlled is the explanatory variable. And then this is like the response. How did they react? Whoever they are, whoever the people are in the study is, how did they react is the response. Like, what is your response? That's the response variable. Whereas the explanatory variable is what we did to somebody. Okay, so it says you want to know the relationship between the amount of time a student spends studying for tests or studying for exam and their grade on the exam. Identify the explanatory and response variable. All right, so what is control? Now this one's not really an experiment. I mean, it is an experiment, but this is just one person, one student, and we want to know if the time they studied versus their grade. So what can be controlled? So you could say, I want you to study for an hour. Or you could say it about yourself. I want to study for 2 hours. I want to study for 3 hours. You can control your studying time. And then the result or the response or how the knowledge reacted would be the grade on the test. So the time, let me do a different color. The time spent studying would be the explanatory variables. And then the grade is the response variable. So you can control the time you spend studying, can't control your grade. So if the time you spend studying is explanatory, the grade is the response. Whatever goes in is the explanatory, whatever comes out is the response. Okay, so besides these 2 variables, explanatory and response, we also have lurking variables. So a lurking variable is another reason why something might happen. So let's just think about the student studying real quick. You have the explanatory of time spent studying, and then we have the response variable of what their grade is on the test. But there's other reasons you could get a good or bad grade on a test besides the time you spend studying. Like you could spend just the right amount of time studying, and then, warning, my examples usually go dark, then your dog dies. or, something terrible happens, that's going to affect your grade also. Like, it doesn't matter how much time you spend studying, you have something terrible happen to you between the studying and the test, and your grade's going to go down. Maybe a more uplifting version would be like, you took the class before, so some of this knowledge is already in your head, or maybe you're just really smart, right? Like you spend a certain amount of time studying, but you're also really smart, so that's going to help your grade go up. So there's other reasons besides literally the time you spend studying to get a grade. Because I promise, if I could tell you, if I could just wave my wand and say, if you study for 3 hours, you will get an A, and that was true, and that was all it took, I bet you a whole bunch of people would study for exactly 3 hours to get that A. Unfortunately, it's not just the studying. There's other lurking variables that come into effect. Okay, so looking at this next example with lurking variables, it says a manager wants to know if cold brew, so it has a higher concentration of caffeine, has an effect on a worker's production before lunchtime. So for 5 days, the manager brews cold brew, and for the next 5 days, just regular hot coffee. The manager found that when the cold brew was brewed, there was more production at the plant before lunchtime. Okay, so it could be that the cold brew was great. It gave them more caffeine. That's wonderful. But there could be other reasons. So let's list some. I'm going to list, it says give 3 examples. I'll list 2, and then you could list the 3rd one. So for example, it's hot outside. Now that's just a fact at my house right now, but it's also hot outside, meaning you don't want to drink hot coffee. So you drink cold coffee. So when there's cold brew, you're like, cool, guy's giving me free cold brew, I'm going to drink it. Next 5 days, you say, well, I know he's going to give me hot coffee today, I'm going to bring my own. I'm going to bring in cold brew. So maybe you just don't drink his coffee the next time, or maybe it's just hot and you just want cold coffee only, you don't want hot coffee. So that could be a reason. Maybe you didn't drink any coffee on the other 3 days or the other 5 days. The next lurking variable is who is working. For example, let me move this up a little bit so you can see the captions. Who is working, meaning, let's just say the first 5 days are Monday through Friday. But then the second 5 days would be like Saturday, Sunday. Oh, let's start with Saturday. Saturday, Sunday, Monday, Tuesday, Wednesday. So maybe these people, these first people, are just better workers. And maybe the people that come in on Saturday and Sunday don't work as hard. I don't know where they're working. What are they making? I don't know what they're doing. But maybe the weekend people don't work as hard. And then you only have a few days with your same old Monday through Friday people. So there's all kinds of things. Maybe it was Christmas. Maybe Monday through Friday was before Christmas. So everyone's excited. And then Saturday and Sunday was Christmas and people are mad that they're working and they're just working slow. I don't know. There's all kinds of reasons. See what I'm saying? Like, just make up something. So you make up the 3rd one. Fill in the blank. You come up with a wacky reason. Why do you think that the first 5 days was more productive? The answer cannot be because of the cold brew. See what I'm saying? Like, any answer, make it silly, not because of the cold brew. Okay, next up. Okay, this page right here, is this all on the same page? One. Okay, all of these words right here in these boxes, put a flag by it, like print this page out, put a flag by it, have this page open during the test. Why? Because it's just vocabulary. Like, you're going to want to open during your homework too. No need to memorize this, just have it available and just reference back to it. Have these examples here, put some other examples from the homework, whatever you want to do, but have these available for the quiz, for the test, and whatnot. Okay, so there's 4 different kinds of scales that we can use when we're measuring something. First one is nominal. Nominal is qualitative, which means words, and not ordered. Words that are not ordered would be like colors. If I said purple, green, yellow, blue, and then I said, which one means the best? None of those words mean the best, right? Like, they're just words. So we could think about like kindergarten, right? Like your teacher's like, here's the yellow group and here's the green group, and like all your marker or, your pencil box, your folders, everything was all color coded. It's just words to like group people, or like, here's the duckies and here's the kitties and here's the cows, like however the kindergarten teacher groups the kids, it's just using words. Now, there is one exception for colors. I'm going to say 3 more colors and you're going to know exactly what order they go in. Gold, silver, bronze. Right? So, okay, so when I say colors, I just mean in general, those 3 colors that I just said would be ordinal, because those are those are words that can be ordered. Doesn't have to be colors. But so we could say like, have you ever taken a survey and it's like bad, neutral, good, like on a scale of 1 to 5, very bad, very good, those kinds of words. So they're word answers, but there's a ranking to them. You can put them in order. Good is better than bad, that kind of thing. Okay, so these 2 are both words. These 2 are both numbers. My dog. Okay, interval and ratio scale, they can be measured. That's meaning they're numbers, and there is an order, but the first one is, it does not have a starting point. So like temperature, oopsies, I'm gonna hit that eraser button a lot. Okay, temperature, like, okay, if you talk about the temperature outside, 50 degrees, 60 degrees, 70 degrees, we know what is hotter and colder. We can order them. We can say this is a hot number, this is a cold number. But then you take it outside of like the outside temperature. You go into like a science lab, you can make things a lot hotter and a lot colder. So it's just kind of like this interval that goes on forever. But there is a specific, like a timeline, right? Like, when did time start? When does time end? But you can put the years in a timeline. Like, I'm gonna do this backwards. Let's see. I think this is the right way. Dinosaurs to like us now, right? Like on the timeline, you know which one came before and which one came after, but it just kind of goes on forever. All my science people out there, like, I'm being super basic in this. I'm not trying to be like, well, technically this 0 is the coldest you can be. No. We're not being that technical, or like the Big Bang Theory. No, not being that technical, just using general ideas to kind of get the point across. Okay, last but not least, a ratio scale, which is numbers, and it has a start and end. So think of like a test score. You're going to get, there is a highest test score you can get. There is a lowest test score you can get. I will never give you a negative test score. Even if you cheat, you're still going to get a 0. You're not going to get a negative. If you do the best you can do, or not the best, if you get a perfect score, then you still are going to stop. I'm not going to give you 1,000,000% on the test, right? 100% is the top. Okay, so looking at this, it says, a website said, who do you like? Who do you like? Do you like Twitter, Facebook, Instagram, or Snapchat? So those are words. So it's our top 2. So the question is, are they ordered or not ordered? Can you just say one of those words and everybody knows it's the best? No. You can have your opinion, like you might like Instagram better and the person next to you might like Twitter better, but that doesn't mean it's true. That's just your opinion. So this is nominal because there's no order to it. It's just words, and you can just answer which one you like, but that doesn't mean one's the best. Okay, manager gave a test. Oh, that was a bad example because I just gave it away. Test scores is going to be ratio. So we see what the, oh golly, what was that? We see what the test scores are, 50, 80, all those test scores right there out of 100 points. So it ends at 100. That's the most you can get. 0 is the worst you can get. That is ratio. So words, top 2, numbers, bottom 2. All right, last part of vocabulary. So we have fancy words to say kind of what I was just saying. So qualitative, Q-U-A-L, that means words. We were just talking about words. And then quantitative would be numbers. So we could have answers that are words. Oh, a typo. I'm supposed to say words. You could have answers that are words. You could have answers that are numbers. If they're numbers, they're the result of counting or measuring. Okay, so which is which? So quantitative, so since it can be counting or measuring, we're going to split them up into quantitative discrete and quantitative continuous. One is the result of counting. One is the result of measuring. So counting is like 1, 2, 3, 4, 5, 6, 7. Okay, I have 7. That was counting. Measuring would be like a scale. Oops, oh, I'm going to use my new eraser now that I can find it. Oh. I like new technology. All right, scale. What else could measure? A thermometer. Oh, I can't spell though, but I can erase. What else can measure? You know, a clock, whatever can measure things, that would be continuous. Counting things would be discrete. So if I said, how many books are in your backpack? That would be discrete because you would be counting the books. If I said, how much does your backpack weigh? That would be continuous because you would be putting it on a scale to measure it. But both of those are quantitative because both answers are numbers. Okay, last example, we have John. First up, he tallies, oops, where's my highlighter? He tallies the number of companies that he calls each week. So tallying is, so how many did you call each week? That answers a number. Since the answer is a number, it's either going to be discrete or continuous. He's counting, he's tallying, he's counting. So that's going to be quantitative discrete because he is tallying or counting the number. Okay, next one. He is tallying, and then he gets the mean number of companies that everybody is calling each week. So yes, he's tallying Johnny's and Susie's and Frank's and everyone's scores, but then he's taking the average. So he has to calculate that number. So it's still a number. That's true. It is definitely quantitative, but this time it is quantitative continuous because he's measuring the answer. The measurement does not have to be a tool. It does not have to be a literal scale is the only way to measure. No, you can absolutely calculate, do a formula to measure something. Counting is just like on your fingers or with a tally mark or, you know, something like that. Okay, enough of that. I just remembered I'm getting my hair done tomorrow. I told you at the beginning, I'm very excited. I will share that video with you when I have it. Until then, have a good day.